All right, so for 9.10, we're talking law of cosines. If law of sines has everything to do with sines, law of cosines obviously has everything to do with cosines. We are still going to be talking about non-right triangles, so these are our only two methods that we have to solve non-right triangles at the moment. The law of sines, like definition, it did it in 3 different ways that all say the exact same thing. So I'm going to ignore these guys right here because I don't care. They're the exact same. I'm going to focus in on this first one. When I talk about the law of cosines, essentially what I'm going to look at is one angle and 3 sides. So you might have all 3 sides and you might be looking for that angle, or you might have an angle and 2 sides and you're looking for the 3rd side. The thing that we are solving for is this angle side pair that's across from each other. Then you will have kind of 2 other side values that are on the wings, I like to call them. It kind of looks like a percent sign when we draw this out, so maybe that helps you remember, or like a division symbol perhaps. Maybe it helps you remember, like you have 1 pair and then 2 things on the sides. When I look at the formula, it also kind of takes this same shape. The thing that we are solving for is either this angle or this side, and they make a pair. Now those are always going to be the first or the last variable in this equation. Everything else in this equation will be filled in. So you will have the B, the C, this B, this C. Everything else will be filled in except for either the little a for the side or the big A for the angle. Any questions on that so far? This is a formula that has to be memorized, so make sure that you're writing it down over and over on your paper so that you get it every single time. It's going to be the same thing. It's kind of Pythagorean theorem-esque, where I have that a squared equals b squared plus c squared. That part is kind of Pythagorean theorem-esque, so it helps me remember that a little bit. The most important part that I want us to see here is this plus and then this negative right here. When you're typing into your calculator, there is a separate button for a subtraction sign versus a negative symbol. I want us to always be using the negative symbol when we type this into our calculator, or you're going to get something called syntax error. If you get syntax error, that's why, because you've got a minus sign instead of a negative. But don't forget that that negative is there. Okay, so let's look at an example and actually figure out what this equation looks like when we use it. It says find E, little e. Little e is the side E, and that forms a pair with this angle E. And then we have these 2 values, 5 and 7, that are kind of by themselves off to the side. Those are like my wings. Okay. So when I set up my equation, E and little e need to be on the ends. Little e is the one that I'm trying to find, and that always is going first because that's the side length. So the side is here, angle is here. It equals, now it doesn't matter which one I pick to be B and C. I'm just going to do 5 squared plus 7 squared plus, I need to remember that negative 2 times 5 times 7 times cosine. And now the thing that matches up with that E is 57. It's a long formula, right? So I am solving for the variable. When I am solving for a side length, this formula is significantly easier. Do you see where this E is? What's the only thing that's attached to that E? It's the squared, right? How do you get rid of something that's squared? What's the opposite of squaring? Caitlin? Square rooting. So we can square root this whole thing and get E by itself. So let's do that. That leaves me with E equals the square root of, I'm going to do a little bit of simplifying here, just a tiny bit, so it's easier to plug into my calculator. 25 plus 49 plus negative 2 times 5 times 7 is negative 70. So you see I just did ever so slightly a little bit of simplifying. But essentially I'm going to throw that whole thing in my calculator now. You could have thrown it in your calculator exactly the way that we wrote it with the 5 squared and the 7 squared. I just find it easier to simplify a teeny bit. But I never want to round anything until my very last step. So avoid it at all costs if you can. So in my calculator now, I can go ahead and type the square root, so second, and then the square root symbol. And now I have 25 plus 70 plus, putting it in parentheses, and I'm not going to hit the subtraction symbol because that's going to get me a syntax error. I want to hit that negative button that's down at the bottom. And then negative 70 cosine 57. Close everything up. I should still be underneath that square root symbol. Hopefully we still see that the square root is on the top. Hit enter. And I got, oh, I did not get the right thing. What did I mess up? Oh, I put 70 up here. Silly me. Sorry, this is supposed to be a 49. 5.98, which is about 6. Did I do that in my notes? No, I wrote it right in my notes. I just did not put it in my calculator correct. So that's about 6.0, and that's the side length. Any questions on that, other than me typing it into my calculator wrong? Okay, moving on. Number 2. Now it says find angle R. If we see find an angle, immediately we should be thinking inverses. I'm going to need to use an inverse somewhere here. So let's pair up what we're trying to find. So R goes with 10, and then I have these 2 things off on the wings. The side always comes first, so the 10 squared is going to come first, equals, and now I have B and C, so 14 squared plus 18 squared plus negative, erase, there we go, 2 times 14 times 18, cosine, and now I don't know the angle, so that's where my variable is going. Everybody good with this formula? So things get a little bit trickier when I'm solving for an angle because look at where this angle is. It's all the way over here, and there's a bunch of stuff that's connected to it. So I'm going to do one simplifying step, and then we're going to have to get R by itself, and I'll show you how we're going to do that. Again, I don't want to have to round. So the simplifying that I'm doing is just like getting some whole numbers. So this is like 100 over here. This is 14 squared plus 18 squared gets me like 520. That's this right here. Plus negative 2 times 14 times 18 is negative 504. Everybody good with that? I just did a little tiny bit of simplifying. And now I need R by itself. Here's R. To get R by itself, I have to think order of operations, PEMDAS, but backwards. So I need to start with addition and subtraction. What's being added or subtracted is first 520. So we need to subtract 520 from both sides. So that's a negative 420. Good. I've done my addition and subtraction, so now I'm moving on to multiplication and division. What's being multiplied or divided to that cosine R? The negative 504 is being multiplied, so I should divide by cosine R. I don't know what just happened. I'm dividing by negative 504. I don't want to round this. I do not want to make that a decimal because then it's going to be wonky. So I'm going to leave this. I can technically simplify this if I want to, but why do extra work? I'm going to leave that as 420 over 504 equals cosine R. From here, now my only step that's left is to do the inverse cosine because I know anytime I solve for an angle, I need to do an inverse. So in your calculator goes inverse cosine of 420 over 504. Inverse cosine, 420, 420 over 504, and enter. So 33.6 is what I'm getting. And that's in degrees. Any questions on this? So obviously solving for angles is a little bit harder than solving for sides, unfortunately. That's just the way it goes. Okay, so this is a long formula. When we put it all together, what would we rather do? Would we rather do law of sines from yesterday, or would we rather do this law of cosines? Personally, I would rather do law of sines any day of the week. It's a much easier formula, less chance for errors. So if I can, that's what I'm going to choose to do above all else. Really, we should never be using law of cosines more than once in a problem. Because once we get one of those angles or one of those sides, we should have enough information to do law of sines. So when I put it all together and I'm solving for an entire triangle, I'm going to take a look at where is the law of sines, if possible. Can I set up law of sines? And if not, I'm going to do law of cosines once and then move on to law of sines. So looking at number 3, I don't have enough information to do law of sines here because I don't have 2 pairs of angles and sides. So instead, law of sines, I'm going to start with 55 and F. And then these are my 2 little wings here. My law of cosines will look like F squared equals 6 squared, maybe 6 squared, plus 6.3 squared, plus negative 2 times 6 times 6.3 times cosine 55. Look at how that F and that 55 are on the ends. I'm not going to do more work than I have to. If you really want to simplify this a little tiny bit, you can. But you can also just square root this entire thing, which is what I'm about to do. So this is F equals the square root of 6 squared plus 6.3 squared plus negative 2 times 6 times 6.3 times cosine 55. Okay, let's type it in. Square root. What did I just say? Square root of 6 squared plus 6.3 squared plus, parentheses, negative, not minus, 2 times 6 times 6.3 cosine 55. Enter. Got 5.7. Does that sound about right? Yeah, we all got 5.7. Fantastic. I'm going to fill that in here so I can use it in my next part. And now I do not want to do law of cosines again. It's much too long of a formula. So I'm going to figure out how can I set up law of sines here. I already have 1 pair, the 55 and the 5.7 that I just found. Let's find a second pair. Let's say to find angle R. I'm going to set up those pairs right there. So that looks like, first, sine 55 over the 5.7 I just found equals sine R over 6.0. I'm going to cross multiply 6.0 sine 55 equals 5.7 sine R. Divide by 5.7. And then I'm solving for an angle. Anytime I'm solving for an angle, I'm thinking inverse. So I know I need sine inverse of 6 sine 55 over 5.7. Everybody good with how we got there? So let's plug it into my calculator and figure out what R is. Inverse sine of 6. Oops, I need to put parentheses around my numerator. I still didn't do it. There we go. 6 sine 55, parentheses to close off my numerator, divided by the 5.7 we just found. I'm getting 59.6. Everybody good with that? Okay. And then really, I don't want to do either one of these again. I don't want to do law of cosines. I don't want to do law of sines. I'm going to look for the easiest method out. The easiest way is to look that I have 2 of the 3 angles in this triangle. And I know that if I have 2 of 3 angles, I can do a little bit of subtraction from 180. So 180 minus 55 minus 59.6 gives me that my angle that is remaining is 65.4 degrees. Any questions on that? Yes? Because it's not a right triangle. So we can only use Pythagorean theorem on right triangles, and these are not right. Any other questions? No. Do we have to do the next level? We're going to set it up. I won't make us do the whole thing. The easiest part of this problem is the 180 minus 32 minus 46. Okay, so we get that angle really easily is 102. Let's do 2 setups. Do I have to do the law of cosines here at all? I don't think so. I have enough angles that I can make a bunch of pairs. So let's do the first law of sines here to get f. This is sine 102 over 16 equals sine 36 over f. Okay, I'm going to let you do the math there, but that's going to end up getting us 8.7 for f. And then again, to find d, I don't have to do any law of cosines. All I got to do is law of sines again. We're going to do sine 102 over 16 equals sine 46 over d. And I believe we get d is 11.8. Okay, so that's all to say. Don't do law of cosines if you don't have to. It's a big, long formula that we don't want to have to do. Try law of sines if you can. Any questions?